this video, I will be explaining chapter 12, introducing probability. First, what is the probability? The probability is a measure of how likely an event is to occur. Then let me explain some definitions. Sample space. We use S for the sample space. What is the sample space? The set of all possible outcomes of an experiment is called the sample space. Then what is the event? A collection of outcomes for an experiment. Now let me explain these two definitions using some examples. Think about the tossing a coin. It has head and tail. What are the outcomes we can expect? It may be H and T. So this is the sample space for tossing a coin. So all possible outcomes. Now let me explain events. Go to the example 1. Let's say sample space is S 1 to 8. Then consider A. What is the event? Event is the collection of outcomes for the experiment. See, 2 is in S, 4 is in S, 6 is in S, 8 is in S. Each element of A are in S. Therefore, we can say A is an event. A is an event of S. How about C? When we go to the elements in C, 1, yes, 1 is there, 2 is in S, 6 is in S, but 9 is not in S. Therefore, C is not an event of S. Why? Here, even 3 elements are in S, but one element, which is 9, is not in S. Therefore, C is not an event of S. Now let me explain equally likely outcomes and how to find the probability of the events. Suppose A is an event, then probability of A we can write PA, that is the number of elements in A divided by number of elements in S. So we can write NA divided by total number of elements in the experiment, that is capital N. So example 2. What is the sample space of roll in a die? It is a 6-sided die, so 1, 2, 3, 4, 5, 6. These are the all possible outcomes we can expect. Therefore, we can write sample space S equal 1 to 6 like this. Then consider this outcome. I say if A is 1. So 1 is in S, therefore A is an event of S. And B is 3. Okay, so same, B is an event of S. So what is the probability of A? Probability of A equal number of elements in A is 1 and total in the sample space is 6, therefore 1 6. And here probability of B equal number of elements in B is 1 and the total number of elements is 6, therefore 1 6. Here also 1 6 and here also 1 6. Both probabilities are equal for this case. Therefore, we can say events A and B are equally likely. Now example 3. A fair die is rolled and the sample space is given as S 1 to 6. It is a Same experiment we discussed just before. Which of the following statements is true? First one. All outcomes in the sample space S are equally likely. Yes, I explained this before, but let me explain again. All outcomes. What are the outcomes here? 1, 2, 3, 4, 5, 6. So what is the probability of 1? It is 1 6. And probability of 2, that is 1 6, because only we have 1 here, 2, therefore 1 6. Similarly, you can write probability of 6, it is also 1 6. Yes, all outcomes in the sample space S are equally likely. First one is correct. How about the second one? The event A, even number. Let me write down even number of this experiment. What are the even number? 2, 4, 6. Probability of A equal what number of elements in A3 and number of elements in A6, 3, 6. You can reduce. This is 1 half. Then B is odd numbers. What are the odd numbers? 1, 3, 5. So, what is the probability of B? Probability of B equal number of elements in B, it is 3, and total 6, it is also 3, 6, or 1 half. A and B have the same probabilities. Therefore, A and B are equally likely. It is also true. Then go to the third one. Third, what is the A? A is even number 2, 4, 6. Yes, that is the probability. We already know it. It is 3 over 6. Then what is the C? C is number less than 4. Okay, numbers less than 4. What are those? 1, 2, 3, right? Not 4, because less than 4. We don't count 4 then. Therefore, probability of C, how many elements in C? It is 3 and total 6. Therefore, you see here, both A and C have the same probabilities. So, we can say the event A and C are equally likely. Yes, that is also true. Therefore, answer for this example, this. All of the answer options are correct. Example number 4. Suppose two balanced coins are tossed. First one, identify the sample space. Okay, now think about two balanced coins. First coin, what are the outcomes? It is head and tail. Consider the second coin. So here, head and tail, head and tail. With the first coin, head, and second coin, head. Similarly, with the first coin head, second coin tail. Let me write this. So S equal first head, second head, first head, second tail. Then how about next? First tail, second head, tail head, and the last tail tail. So these are the all possible outcomes for two balanced coins. So this is the sample space. How about the one coins two times? Yes, that is also the same. Then you can consider this is the first toss and this is the second toss. Event A, both coins show heads. So what are the elements then? Both coins show heads, therefore first head and second head. So this is the only element for A. Then what is the probability of A? Probability of A equal number of elements in A is 1 and total is 4, that is 1/4. Then events B, just one coin shows head. It means just one head, right? So head and T or T and head. So how many elements in B? 2 elements, total 4, that is 2/4, or you can say 1 half. Now let me explain example number 5. Consider tossing a pair coin 3 times. Okay, one coin, this is the first time, first toss, and second time, and third time. Then, first time we can expect head or tail. Second time also head, tail, and head, tail. Third time head, tail, head, tail, head, tail, head, tail. Right. Let me explain this. First time head, second time head, third time head. So how do we write this S? The sample space H, H, H. Next one, first time H, second time H, third time T. Therefore, H, H, T. Next one, first time H, second time T, third time H. So H, T, H. Then next H, T, T, H, T, T. Similarly, we can go with next one like this. So I will write the elements T, H, H, T, H, T, 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 H, T, T, T. So that is the sample space, all possible outcomes. This one is tossing a pair coin 3 times, right? Then how about the 3 coins one time? Actually, it also has the same sample space here. Event A, getting all heads. Right. So what are the elements getting all heads? We know it 3 times heads, therefore H H H. A is an event of S because that's all elements of A are in S. So probability of A equal number of elements in A is 1, total is 8, therefore 1 8. Then B, getting exactly 2 heads, exactly 2 heads. Then what are the elements of B? H H T 2 heads, H T H 2 heads, T H H 2 heads. That's it, right? So those are the only elements getting 2 heads. Therefore, what is the probability? Probability of B equal number of elements of B. It is 3, total 8, therefore 3 over 8. The C is getting at least 2 heads. So at least 2 heads mean maybe 2 or 3, right? Maximum here 3. Therefore, we can consider HHH, then 2 heads HHT, then HTH, THH. That's it. So, how many elements of C? Probability of C equal 4 elements divided by 8, that is 1 half. Example 6. Suppose two balanced dice are rolled. List the outcomes constituting following events. First of all, think about the sample space. First die and second die. So, how many outcomes for the first one we can expect 1 to 6, right? And the second one also 1 to 6. So how many outcome for the sample space? So let me show you using a graph. You see here first one 1 and second one also 1. First one 1, second one 2. Similarly, we can think about 36 elements, right? 36 possible outcomes. So, sample space 36 outcomes. Since the dice are fair, each outcome is equally likely. So, what is the probability? Each outcome has probability 1 over 36. Then, how do we write this as a sample space? Here, S is 1 comma 1, 1 comma 2 up to 6 comma 6. This is the sample space for two balanced dice or one dice rolled twice. A, the sum of the dice is 11. Right, sum of the dice is 11. What are the outcomes for that part? So 11 sum, so you see here 5 plus 6 is 11, this one, and 6 plus 5 is 11. So what are the elements of A? It is 5 comma 6 and 6 comma 5. So probability of A, number of elements of A, it is 2, and number of elements of S, 36, 2 over 36 or 1 over 18. Then go to the B. The both dice come up the same number. Okay, with the same number. So what are the elements of B then? Same number you see here, 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. Therefore, we can write B equal 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. So what is the probability of event B? Probability of event B, number of elements 6, total 36, therefore 1 6. Then C. The sum of dice is 12 or less. Okay, now calculate the sum of these each outputs. So here sum is 2, here 3, here 4, here if you go to this 5, similarly here 12. So we are looking for 12 or less. Actually here sum of each outcomes is 12 or less than 12, right? Therefore C equal S. So what is the probability of C? Number of elements 36, and here also 36 total. Therefore probability is 1. Now example 7. In each of the following situations, describe a sample space S for the random phenomenon. Right, first one. A basketball player shoots 3 free throws. You record the sequence of hits and misses. I use H and M for the hits and misses respectively. So what is the sample space? He tried 3 times, therefore he can get success for all 3, right? Or maybe first 2 but last one. Or first one, second one miss, and last one. Similarly, H, miss, 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 H, H, miss, H, miss, 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 H. The last one, M, 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 all miss, right? Then second one, a basketball player shot 3 free throws. You record the number of baskets she makes. A number of baskets she makes now, right? So S equal, how many number of baskets she made here? I say 3. How many here? 2. Here 2. Here 1. Here 2. 1. 1. Here no any hits. Therefore I use 0. Then what are the elements of C? You see 0, 1, 2, 3. Therefore, we write 0, 1, 2, 3. That is the sample space for the second one.